All right, we're starting Unit 6, which is logarithmic functions. But before we actually talk about logs, we're going to actually talk a little bit more about exponential functions and their inverses. So I want you to read what's here. And then I want you to actually answer number 1 and 2 using your graphing calculator, because you're going to actually need to put those equations into the graphing calculator and scroll the chart to look at the domain and range. So pause the video, do what I just said, and then come back and we'll talk a little bit more. All right, so hopefully what you read about an exponential curve is that it's always going to go through quadrants 1 and 2, pass through point 0, 1, and never touch the x-axis. It's going to come very, very close, but it's never going to touch it. So therefore, my x-axis is going to be called my asymptote of that function. All right, hopefully for number 1, your answer was choice 4, because when you looked at all your values of x, all of those numbers were there. And hopefully your answer for number 2 was choice 2, because -2 did not appear on the chart for your y values. Let's go on and take a look at this graph here. They want us to graph an exponential curve. They gave us an interval, which means we're not going to have any arrows. So we're going to put it in the calculator. We're going to go y equals y1 equals 3 raised to the x, second graph. We're going to give the chart from -2 to +2. And we're going to get 0.1 repeating, 0.3 repeating, 0, 1, 1, 3, 2, 9. Whoops, 2, 9. Okay, let's actually graph this and see what we have. -2.1, -1.3, 0, 1, 1, 3, and 2, 9. Connect the dots without any arrows, and we're going to label it y equals 3 raised to the x. It's definitely an exponential curve because it's in quadrants 1 and 2 and passes through point 0, 1. Okay, let's go on to the next page. So an exponential curve. All right, we're going to skip number 4, and we're actually going to go down to number 5. In number 5, they want you to graph y equals 1/4 raised to the x in the interval from -2 to +2. So again, no arrows. And on the same set of axes, they want me to sketch the graph of y equals x plus 5. All right, I want you to pause the video. I want you to do part A and B and then come back and see yours versus mine. Okay, let's take a look at it. Does yours look like mine? The first one was an exponential. The second one was a line. Okay. So, part C says, use the calculator to find the value of x which satisfies the equation. Well, the value of x would be the x of a point of intersection. My point of intersection is right here. And I know what it is, but they told me to use the graphing calculator, which means they want me to show the steps. So if I was to use a graphing calculator to find the point of intersection, I would go y equals, and in y1 I'd plug in 1/4 raised to the x. y2 I would plug in x plus 5, and I would then hit the graph button, and then go second trace, and we would choose number 5 for intersect. And if we actually traced it, we would end up with the point that we actually can see, which is -1/4. But that's my point of intersection. They want me to find the value of x that satisfies it. Well, the x would be the x value of my point of intersection, so my answer would be x equals -1. Okay, let's go on to the next page. Exponential functions and their inverses. If a function is reflected in the line y equals x, the result is called an inverse function. And we already know inverse notation from the last unit, f to the -1. But they're saying that the rule for reflecting over the y equals x is to switch the x and y, which is true because when we did inverses, the rule was to switch the x and y and solve for y. But when we're actually going to switch the x and y to an exponential equation, we're not going to be able to get it equal to y because we can't get rid of the y since it's an exponent. So what are we going to do? Well, let's see what we're going to do. Take a look at number 6. It says sketch the graph of y equals 2x. So I want you to pause the video, do that, and come back. They didn't give us an interval, so you're going to be able to use arrows. I suggest you only do your chart from -3 to +3 so it doesn't get too out of hand. All right, again, pause the video, do it, and come back. Take a look at yours versus mine. I have my arrows because I don't have an interval, and there's my chart. So let's go on to part B together. Part B says, on the same set of axes, sketch its inverse. Well, we remember the inverse would be x equals 2y, and there really is no way to get y by itself to put in the calculator. So the only other thing that I could do would be to actually switch the x and y. So I'm going to actually do that to my chart. So the inverse is going to be, and this is part B, I'm going to have 0.125 -3, 0.25 -2. See, I'm actually switching the x and y. 0.5 -1, 1, 0, 4, 2, 8, 3. All right, let's graph the inverse. 0.125 -3, 0.25 -2, and I'm just eyeing it the best I can here with a stylus. 0.5 -1, 1, 0, 4, 2, 8, 3. Connect the dots, put arrows on the ends, and there's my actual inverse. Now let's make sure that is the inverse. Inverse means it's reflected in the line y equals x. Well, here's the line y equals x. It would be 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2. Get it? Y equals x. The x and y have to be exactly the same. If I draw that line, y equals x, does it make sense? Was the original exponential curve reflected in that line to get its inverse? Yes, it was. All right, for part C, they want us to write the equation of the graph drawn in B. Well, this is definitely B, and isn't the equation what we just talked about earlier? It's switched the x and y, so it's going to be x equals 2y. Now, why did I just show you how to graph the inverse of an exponential curve? Because the inverse of an exponential curve is called a log. A log is the inverse of an exponential curve. Let's take a look at the properties. Properties of a log lies in quadrants 1 and 4. Doesn't that inverse lie in quadrant 1 and 4? It never touches the y-axis. This one never did either. Passes through 1, 0. Yes, it does. It goes through 1, 0. So basically, the properties of a log are definitely the properties of the inverse of an exponential, so a log is the inverse of an exponential. It would be a good idea to take a look at these properties and kind of memorize them so that you know the difference between an exponential and a log. All right, now we're going to actually graph a log. And in order to graph a log, we have to do what's called change of base. Change of base is where we type in the log of the last term divided by the log of the subscript. Well, what do you mean by subscript and last term? Well, let's take a look at this little example I have written here. Log of base b of x. So if I do change of base, it's going to be log of the last term, so log of x divided by log of the subscript, so log of b. B is your subscript. It's the little number to the right-hand bottom corner of the word log. So in order for you to actually graph a log, you're going to have to do change of base because that's the only way you can get rid of that little subscript because you can't put a subscript into the calculator. All right, so take a minute, copy that down, and come back, and we're actually going to do number 7 together. So we're actually going to sketch the graph of y equals log base 4 of x. All right, we can't put it in the calculator like that, so we're actually going to do what's called change of base. So we're going to do y equals log of x divided by log of 4. Okay, so we're going to go y equals y1 log of x divided by log of 4. Remember, if your calculator opens up a set of parentheses, you have to close it. And then we're going to go second graph. So put that in your calculator and let's take a look at the chart. If you look at the chart, you have no answers to any negative numbers of x values. That's because you're never allowed to take the log of a negative number. So all your values have to be greater than 0 for your x's. So we're going to go do our chart from, let's say, 1 to 6. All right, so we have 0.5, 0.7928, 4 is 1, 5 is 1.1181, and 6 is 1.2925. Let's graph this log and see if it definitely fits the description it's supposed to. All right, 1, 0, 2.5, 3.7, 4, 1, 5 a little over 1, 6 a little over than that. Put arrows on the ends because they didn't give me an interval. It definitely is a log because it definitely is in quadrants 1 and 4. If I was to continue and actually graph 0.5, 0.25, it would definitely come down to the negatives, but it will never touch the y-axis because you're not allowed to go on the other side of the y-axis because we're not allowed to graph any logs of a negative number. So it definitely fits all the categories of a log, so yes, it's definitely a log. So we're going to label it y equals log base 4 of x, its original equation. All right, let's take a look at the last question for today. Determine the equation of the function shown in the graph below. Well, it's definitely a log and not an exponential because it goes through quadrants 1 and 4, so I'm actually going to cross out choice 2. So now I'm down to 3 choices. I'm not sure which choice it is. I want to look for a point on that graph that I can actually look on the chart for each of these. I don't want to use 1, 0 because every log has 1, 0. How about if we look for, oh, there's a good one. How about 4, 1? So let's put choice 1 into the calculator and go through the chart and see if 4, 1 appears there. Well, again, how do we put in the calculator? We're going to have to use change of base. So y equals, y1's going to be log of x divided by log of 2. And then hit second graph and take a look at the chart. Do you see 4, 1 there? You're right, you don't. It's not there. All right, pause the video, do the same thing to 3 and 4 and see if either of those contains 4, 1. If it does, then there's your answer. All right, hopefully you did so and you chose choice 3 as your answer. If you have any questions about what we did in class today, we'll go over it again tomorrow because tomorrow we're going to practice a couple more graphing problems. See you in class then.